Hey, it's Mr. Lowry. I wanted to help introduce your homework for, this is for day 2, for A day, which would be on 11/24. And for B day, it's, this week's kind of weird, but this would essentially be the homework for following Monday's lesson, or following Tuesday's lesson. So we covered 3.1 and 3.2 in the last video. We kind of talked about some things there and did some proofs. I just wanted to show it to you in the book really quick so you can see where things are. Now, what I wanted to point out as well is that the order that the book proved things in is not exactly the same order that I proved things in class or in the video that you watched. So that's okay. It's not that big of a deal, but they start with this idea of corresponding angles being congruent. They just kind of start with that from the get-go. So this is on page 133. Let me see if I can zoom in here. And the pages are a little glossy, so that's kind of shiny here. But this is the corresponding angles postulate. Now they say it's a postulate, which means they're not going to go about proving it. They're just going to assume that it's obvious to you. So they're saying, look, these corresponding angles, 1 and 5, they're going to be the same angle if these lines are parallel. Now we kind of, like I said, we proved that a little bit, starting with Euclid's 5th postulate. They started with it as kind of a postulate, but it's still a good exercise. If you want to use this idea that corresponding angles are congruent, you can do that. You can call it the corresponding angles postulate or the corresponding angles theorem. We called it a theorem because we proved it. Again, the book calls it a postulate, but I'm not going to be super picky about that. Okay, on the next page, this is page 134, you have 3 theorems. The alternate interior angles theorem, that alternate interior angles are congruent. You have the consecutive interior angles theorem. That's that consecutive interior angles are supplementary. And then you have the alternate exterior angles theorem, and that's that alternate exterior angles are congruent. So we just proved these in the last video. Actually, we started with 3.2. This is essentially Euclid's 5th postulate. Basically the same thing. So if you want to use in a proof as a justification consecutive interior angles theorem, you're welcome to do that. If you want to say Euclid's 5th postulate instead, you can absolutely say that too. Those are essentially the same idea. And then we proved these guys in the last one. So starting with a different postulate and proving things in a different order, that's kind of what's happening here, but essentially the reasoning is very similar. Okay, now in your homework, we're going to start here in number 3. Okay, so we're talking about this figure right here. And what it's asking is, how many angles do you need to know to get all the other angles? Well, if you think about this for a second, let's say we had angle 1. Well, we got vertical angles for angle 3. We got a linear pair for angle 2 and angle 4, so we could find those pretty easily. We also have corresponding angle to give you angle 5. You also, if you knew 1 and then you know 3 because they're congruent vertical angles, but then 3 and 5 are alternate interior, and 4 and 6 are alternate interior. So like, if you have one angle, you basically can use a theorem or a postulate to get all the other ones pretty quickly. And that's exactly what you're going to do in the next set of problems. So starting with 14 and ending with 25, we're going to use these diagrams here to find other angle measures. So use vertical angles. Vertical angles are congruent. Know that. Use linear pairs. Use the supplement theorem. If 2 angles form a linear pair, they're supplementary. Okay, that's the supplement theorem. You can use the other things we just proved, right? We know that consecutive interior angles are supplementary. So, 2 and 5 add up to 180. We know that alternate interior angles are congruent. So you could say 2 and 8 are the same angle measure, or 3 and 5 are the same angle measure, right? We know that corresponding angles are congruent. We know that alternate exterior angles are congruent. So we have all these theorems about angles, basically 6 theorems: vertical angles, supplement theorem, which is about linear pairs, alternate exterior angles theorem, alternate interior angles theorem, corresponding angles theorem, and either Euclid's 5th postulate or the consecutive interior angles theorem. All those things. So once again, just so if you're confused, we got these 3 this guy. It's from page 133 and 134. And then the two we proved last week, which were the vertical angles theorem and the supplement theorem. So the one thing that I'm going to have you do a little bit differently than it says in the book, so let me see if I can line this up better, is I want you to justify what you're doing. Okay, don't just give me a number. That's too easy. You're not doing a whole lot of reasoning there. So if you know that measure of angle 9 right here is equal to 75, and you want to tell me what the measure of angle 6 is, or the measure of angle 5 or whatever, tell me what theorem or postulate you're using to get there. Okay? Do a little bit of reasoning. Say, look, 9 and 5 are corresponding angles, therefore they're congruent. So angle 5 has to be 75 degrees. Something like that, right? What about angle 3? Okay, well, angle 3 is right here. Where's angle 9? Angle 9 is right here. If you ignore line M for a second, and you just look at L and N, which are parallel to each other, 3 and 9 are alternate interior angles. So if you're like, cool, measure of angle 9 is 75, angle 9 and angle 3 are congruent because they're alternate interior angles. Therefore, measure of angle 3 is 75 degrees. You don't have to write a whole proof. I just want you to use what theorem or postulate you're using to get that relationship. Okay? And you're going to do that all the way through 25. Now, 20 through 25 is a different figure, so you're going to have to pay attention to that. All right, after that, you're going to do some algebra, right? So here we got this figure. Okay, so let's talk about what we have here. We got two angles here. Now, these have to add up to 180, right? And these two have to add up to 180. And this one have to be equal to each other because they're alternate interior. So we got a linear pair here. We have consecutive interior angles here that have to be supplementary by Euclid's fifth postulate. And we have alternate interior angles that have to be congruent. So use those ideas, which two add up to 180. Let me zoom in here. Use this idea, these relationships. These two add up to 180. These two are congruent, etc. You got to solve for those missing variables and plug them back in. Okay, I want you to think about it. I want you to reason through it. I told you what you need to use to get there. You're just going to kind of have to think through the algebra steps. If I show you how to set it up, I think that takes away too much of the problem for you, and I want you to kind of think about this. So after you do 25, you're going to jump back to 11, because I think practicing on 14 through 25 will help you get you ready for 11. Okay, 32 is really similar, right? So let's talk about what we have here. So 4x and this guy down here, these are alternate exterior angles. Okay, so we know something about those. We also have some vertical angles in here. So you could add an angle, like these two angles are congruent because they're vertical angles. So you could, use a vertical angle here and then show that these two have to add up to 180. So this angle right here, right underneath the 4x angle, is also equal to 4x because these are vertical angles. So you could do that. So use your vertical angles, use your linear pairs, use your other angle relationships, corresponding angles, alternate interior angles, and consecutive interior. Use the facts to set up some equations and solve these problems. Vertical angles is going to help you a lot, so that's a good one to have in your back pocket. Okay, so that should help you get started and just kind of introduce what I expect of you. Now remember, 14 through 25, you need to write a justification. Not a full proof, you just need to write what theorem or postulate you're using to reason through to get that angle measure that you're looking for. Okay? Good luck, and I'll see you guys in class back next week, and have a happy Thanksgiving.